The navigation skills of blind ants are indeed remarkable and have been the subject of scientific study. Despite lacking the ability to see, blind ants are capable of navigating complex environments, finding food sources, and returning to their nests with precision. They achieve this through a combination of sensory mechanisms and strategies developed over millions of years of evolution. In this video, we discuss in detail the remarkable navigation skills of blind ants. So if you are new to this channel, then subscribe to my channel. Let's back to the video. Tactile sensing. Blind ants heavily rely on their sense of touch to gather information about their surroundings. They have sensitive antennae that can detect chemical and physical cues in their environment. As they move along their path, they use their antennae to touch and explore the surfaces they encounter. By feeling the textures and contours of the terrain, they can create mental maps and navigate based on these tactile cues. Chemical signaling. Ants communicate with each other using chemical signals called pheromones. Blind ants utilize these pheromones to mark their paths and create trails. When an ant discovers a food source, it lays down a trail of pheromones as it returns to the nest. Other ants can then follow this chemical trail to find food. By reinforcing and amplifying the pheromone trail with each ant's contribution, the trail becomes stronger and more attractive to other ants, guiding them to the food source. Path integration. Blind ants are also skilled at path integration, a navigation strategy that involves keeping track of distances and directions traveled. They possess an internal odometer that estimates the distance covered based on the number of steps taken and the duration of their movements. Additionally, they have a sun compass mechanism, where they gauge the direction by sensing the position of the sun or skylight. By combining these measures, blind ants can calculate the relative position and orientation of their nest or other points of reference. Landmark recognition. Although blind ants lack visual perception, they can still recognize and use landmarks as navigational cues. These landmarks can be objects such as rocks, plants, or irregularities in the environment. By memorizing the locations and arrangements of these landmarks, ants can create mental maps to guide their movements. They establish spatial relationships between landmarks and use them as reference points during their journeys. Social interactions. Blind ants are social insects that work collaboratively in colonies. They can communicate with nestmates through touch, pheromones, and vibrations. This social interaction plays a crucial role in navigation. When an ant is unsure of the correct direction, it can interact with nearby ants, receiving guidance and following their lead. Collective decision-making and coordinated movement within the ant colony contribute to successful navigation, even without visual cues. Orientation without vision. Blind ants lack the typical visual cues that many animals rely on for navigation. However, they have developed alternative strategies to maneuver effectively in their environment. Sun compass navigation. One of the key factors in the navigation of desert ants is their ability to use the sun as a compass. They have specialized light-sensitive cells, called photoreceptors, on their bodies, which allows them to detect the polarization pattern of sunlight. This helps them determine the direction of the sun, even on cloudy days when the sun itself may not be visible. Path integration. Another critical skill is path integration, which involves keeping track of the distance and direction they have traveled from their starting point. To achieve this, the ants use their leg movements to measure the distance covered and rely on internal mechanisms to track direction changes accurately. Odor trail following. Desert ants can leave pheromone trails while foraging for food. These trails act as cues for other ants to follow and provide a way to return to the nest even if they get lost during their journey. Tactile sensing. Antennae play a crucial role in their navigation. They use their antennae to sense the texture of the ground and detect obstacles, which helps them avoid collisions and find their way around the terrain. Combining strategies for efficient navigation. Blind ants do not rely on a single method for navigation. Instead, they use a combination of the strategies mentioned above to create a comprehensive navigation system. By integrating information from the sun compass, path integration, landmark learning, pheromone trails, and tactile sensing, they can successfully forage for food and find their way back to their nests, even in challenging and vast desert landscapes. Research implications. Studying the navigation skills of blind ants has far-reaching implications beyond understanding their behavior. It has inspired researchers to develop innovative algorithms for robotic navigation, known as ant-inspired algorithms, or ant colony optimization. These algorithms mimic the foraging behavior of ants and have been applied to various real-world problems, such as optimizing logistics, routing, and network optimization. In conclusion, the remarkable navigation skills of blind ants demonstrate the power of adaptation and evolution in the natural world. Their ability to use a combination of strategies, such as sun compass navigation, path integration, landmark learning, odor trail following, and tactile sensing, showcases the brilliance of nature's solutions to challenges. Understanding these mechanisms not only enlightens us about the animal kingdom, but also has practical applications in robotics and optimization algorithms. I hope so now you will understand the remarkable navigation skills of blind ants. Thanks for watching my content. If you like my content, press the like button and subscribe to my channel and press the bell icon for upcoming videos. Thank you. Goodbye.